The universe appears silent, a vast expanse of darkness where light itself takes billions of years to travel between stars. Yet hidden within that silence, carried across oceans of time, come whispers brief, fleeting signals etched into the background hum of the cosmos. They arrive without warning, without repetition, a single flash of meaning in the static of eternity. For centuries, the sky was thought to be mute, but modern instruments revealed otherwise. With radio telescopes pressed against the heavens, humanity discovered that the universe does speak, though its language is cryptic and elusive. These signals are not the gentle, predictable rhythms of stars or the steady pulse of planets orbiting their suns. They come as sudden bursts, sharper than lightning, brighter than galaxies. For the fraction of a second they exist. Millisecond. Pulses of energy, more powerful than anything humanity can conceive, reach Earth from distances beyond imagination. Some appear once and never again. Others repeat, but without order, like a pattern written in a language no one can yet read. Scientists ask whether they are the echoes of cataclysms, the collapse of giant stars, the crack of magnetic fields tearing apart neutron stars, or whether something deeper lies within them. Perhaps they are cracks in space-time itself. Perhaps they are signals of intelligence, artificial beacons from civilizations older and more advanced than our own. Each possibility stretches the boundary of understanding, forcing us to reconsider not only what the universe is, but what it means to listen. In these whispers, humanity confronts an ancient question. Are we alone in the void, or is the cosmos itself trying to speak? The answer remains hidden within the static, waiting for ears patient enough to hear and minds bold enough to wonder. In the early decades of the 20th century, the universe was thought to be mute. The night sky shimmered with stars, but beyond their visible light, no one imagined that space was speaking in frequencies the human ear could never perceive. It was an age when astronomy belonged to glass lenses and photographic plates, too silent. Observations of planetary paths and stellar movements traced in the stillness of night. Yet, in 1932, in a field in New Jersey, a young engineer named Karl Jansky stumbled upon something that would change the way humanity listens to the cosmos forever. Jansky was not an astronomer, but a radio engineer, working for Bell Telephone Laboratories to investigate sources of static that interfered with long-distance communications. His instrument was a strange, rotatable antenna, a contraption that his colleagues nicknamed Jansky's merry-go-round. For months he scanned the skies, charting sources of noise, thunderstorms nearby, storms farther away, and finally, something inexplicable, a steady hiss of radio waves that rose and fell with the daily turning of the earth. At first, it puzzled him. The signal did not match terrestrial interference, nor did it align with the sun's position. Patiently, he realized that the source was fixed among the stars. It emanated from the heart of the Milky Way itself, a direction near the constellation Sagittarius. In that discovery, the silence of the universe was broken. Space was not mute at all. It was alive with hidden voices, broadcasting across wavelengths invisible to human eyes. At the time, few grasped the significance. Jansky's discovery made little impression on astronomers who remained rooted in optical tradition. It was a quiet beginning, nearly overlooked, like the first faint knock at the door of an unimagined future. But that door had been opened, and within decades, others would step through. In the years that followed, a new science emerged. Radio astronomy. Grote Reber, a radio engineer inspired by Jansky, built one of the first true radio telescopes in his own backyard, his parabolic dish, resembling the satellite antennas that would later dot the Earth, charted the radio sky and revealed a universe that looked entirely different from what optical telescopes had shown. Stars were not the only storytellers. Galaxies, nebulae, and cosmic remnants blazed in frequencies human eyes had never seen. Slowly, humanity realized that the universe was not silent but filled with a vast, hidden symphony. By the mid-century, this realization gave rise to monumental instruments. In England, Sir Bernard Lovell constructed Jodrell Bank, a towering dish capable of scanning the heavens for radio waves with unprecedented sensitivity. In Puerto Rico, carved into the lush hills, the colossal Arecibo Observatory was built, spanning 300 meters across, its surface catching whispers that had traveled billions of years. These were ears pressed against the cosmos, machines designed not to look at the universe, but to listen to it. And when they listened, they found not only the expected hum of galaxies and the hiss of background radiation, but also anomalies, fleeting bursts, sudden spikes, strange interruptions in the otherwise steady flow of cosmic static. At first, these were dismissed as interference, airplanes, radar signals, or equipment errors. Yet some anomalies persisted, so fleeting and faint they lingered at the edge of perception, as though the universe was sending signals too subtle to decode. The true shock came in 1967. Jocelyn Bell Burnell, then a graduate student at Cambridge, was operating a newly built radio telescope designed to study the scintillation of distant quasars. As she pored over the miles of chart paper that streamed from the instrument, she noticed something odd, a series of sharp, regular pulses occurring every 1.3 seconds with astonishing precision. At first, she suspected noise. Perhaps it was interference from a nearby source, or some quirk of the instrument itself. Yet the pulses returned, night after night, steady and unwavering. The signal was so regular, so clock-like, that the research team jokingly labeled it Eligemi, little green. It was the first time in history that a serious scientific instrument had detected a repeating signal, so eerily artificial in character that alien intelligence could not be immediately dismissed. Of course, skepticism prevailed. Further study revealed the source, a rapidly rotating neutron star, the collapsed core of a massive supernova. The object, later named a pulsar, was unlike anything previously imagined, a city-sized sphere of matter, denser than atomic nuclei, spinning with unimaginable speed and emitting beams of radiation like a cosmic lighthouse. As its beams swept past Earth, it produced the regular pulses Bell Burnell had seen. The discovery was monumental. Not only had astronomers uncovered a new class of celestial objects, but they had also realized that the universe was filled with hidden rhythms. Stars could tick like clocks, sending their heartbeat across the galaxy. Space was not a void, but a stage for phenomena so exotic that even the boldest theories struggled to keep pace. Yet beneath the scientific triumph lay a deeper shift. For a brief moment, humanity had confronted the possibility of hearing another intelligence in the cosmos. The fact that the signal turned out to be natural did not diminish the wonder. Instead, it expanded it. Nature itself was stranger, more creative, more alien than any imagination had yet conceived. The pulsars were not voices of other civilizations, but they were voices nonetheless, voices of dead stars, whispering across the gulfs of time. The emotional resonance of this discovery was profound. For millennia, humanity had looked at the stars in silence. Now, the stars had answered back. The coded rhythms of the cosmos were not human, but they were real. And they hinted at a universe alive, with secrets waiting to be deciphered. Every unexplained anomaly, every sudden burst of radio energy, became a question mark hanging in the night sky. By the late 1960s, the foundations of a new way of knowing had been laid. Radio astronomy was no longer a fringe pursuit. It became central to astrophysics, revealing black holes, mapping distant galaxies, and uncovering the faint glow of the cosmic microwave background, the afterglow of the Big Bang itself. Yet even as mainstream discoveries accumulated, the anomalies remained. Some bursts could be explained, others dissolved into the noise, but a few resisted every effort at explanation, lingering as enigmas on the edge of knowledge. The origins of the mystery were humble, a faint hiss discovered by Jansky, a graduate student's meticulous eye-catching, strange pulses on chart paper. But from those beginnings, a question was born that would grow to dominate the next century of astronomy. What else was out there, hidden in the static? Were these signals echoes of cosmic violence, or something altogether stranger? The story of mysterious signals had begun not in the grand halls of theory, but in the quiet patience of listening, of sifting noise for meaning. And as the instruments grew larger, sharper, and more sensitive, so too did the scope of the mystery. Humanity had learned that the universe was not silent, but it had yet to learn what the universe was trying to say. The discovery of pulsars marked not just a scientific revolution, but an existential awakening. For the first time, a signal had been detected that mimicked intention. It was as if the cosmos itself had chosen to speak in regular intervals, like a heartbeat resonating across the dark. The nickname Little Green Men began as a joke, yet it carried within it the nervous weight of possibility. If such signals were natural, then nature was capable of weaving patterns so precise they could be mistaken for artifice. If they were not, then humanity had just brushed against another intelligence in the abyss. Either answer would have been profound. Jocelyn Bell Burnell's meticulous persistence in identifying those strange pulses reshaped not only astrophysics, but the very way humanity regarded its relationship to the universe. The pulsar was revealed as a neutron star, the compressed corpse of a massive star that had collapsed under its own gravity, packing the mass of the sun into a sphere scarcely larger than a city, its rotation preserved from the dying stars. Momentum spun the magnetic field into a colossal engine, spraying beams of radiation into the void. As those beams swept past Earth, they appeared as clockwork pulses, an interstellar metronome more precise than any instrument built by human hands. That such objects existed was a revelation. That their voices could be heard across the cosmos was nothing less than humbling. From that moment onward, radio astronomy was transformed from a fledgling curiosity into a window onto the most extreme frontiers of physics. What had begun with Jansky's merry-go-round antenna in a New Jersey field had now matured into an empire of listening machines scattered across the Earth. Massive dishes like Jodrell Bank tilted their ears to the heavens, while the Arecibo observatory, suspended above a vast Puerto Rican sinkhole, became a cathedral of listening. These structures were not simply instruments. They were symbols of an evolving human instinct, the instinct not only to look at the stars, but to hear them. The discoveries that followed reinforced this instinct with breathtaking regularity. Pulsars became laboratories for studying gravity and matter under conditions impossible to replicate on Earth. Quasars, bright, violent galaxies powered by supermassive black holes, revealed themselves through their radio emissions. The faint glow of the cosmic microwave background, discovered in 1965, whispered of the universe's fiery birth. Each discovery deepened the sense that the cosmos was not a silent void, but a living archive, speaking in frequencies woven into the very fabric of spacity. And yet, alongside these triumphs, the mysteries lingered. The new instruments occasionally picked up anomalies, sudden spikes, sharp bursts of static energy that seemed out of place. Many were dismissed as terrestrial interference, the byproducts of radar, satellites, or atmospheric reflection. Others faded into the background, never to be heard again. But some remained, recorded on miles of chart paper or magnetic tapes, their origins stubbornly unclear. These fleeting voices seemed to hint at something unresolved, something beyond even the bold new physics of the age. The deeper humanity listened, the more the universe seemed to reveal not order but strangeness. Every triumph carried with it new questions. Were these signals natural, born of collapsing stars, flaring quasars, and magnetic storms, or were they something else, phenomena so alien they resisted immediate categorization? The discovery of pulsars had taught astronomers that the line between natural and artificial could blur. The cosmic processes could mimic intention with uncanny precision. That lesson lingered in every unexplained burst of static, every anomaly written into the margins of the data. By the close of the 1960s, a transformation had occurred in the human imagination. The cosmos was no longer a distant, mute expanse. It had become a vast ocean filled with voices, some familiar, some utterly mysterious. The act of listening itself took on a new weight. To tune a telescope to the sky was not simply to gather information, but to join a conversation older and larger than humankind. For the first time in history, humanity was not merely observing the stars, it was waiting for them to answer. The first signal struck with a strange duality, wonder and unease. When the rhythmic pulses uncovered by Jocelyn Bell Burnell emerged from the noise in 1967, they did not fit the categories that science had prepared for. They were too precise, too measured, too deliberate in their repetition. For a world accustomed to cosmic chaos, two stars that burned, exploded, and decayed with little concern for order, the signal carried the unnerving flavor of intention. It was as though a distant metronome had been set against the infinite silence of the void. Scientists at Cambridge faced the question with cautious humor. The notation LGM1, short for Little Green Men, was scrawled beside the anomaly, both a joke and a shield against the gravity of the thought. What if the signal was not a product of nature at all? What if it was the first true evidence of another intelligence reaching across the void? For a fleeting moment, the possibility could not be dismissed. The data was clear, the pulses steady, the implications staggering. But science, disciplined and skeptical, demanded restraint. Extraordinary claims required extraordinary evidence, and the history of astronomy was littered with illusions. Canals on Mars, mysterious lights in the sky, misread instruments that whispered promises of worlds that were never there. The Cambridge team pressed forward carefully, eliminating terrestrial interference, checking their equipment, and cross-verifying their results. The signal held, and soon more were found. Different parts of the sky revealed similar pulses, each regular, each precise. The idea of alien transmitters began to fade beneath the weight of repetition. It was unlikely that multiple civilizations across the cosmos would reveal themselves all at once, all by the same method. The truth, as it emerged, was no less extraordinary. Pulsars, neutron stars spinning like lighthouses, beaming radiation in perfect rhythm. Relief came with the explanation, but also a trace of disappointment. For a moment, humanity had brushed the edge of an answer it had long sought, only to be reminded that the cosmos itself was stranger than fiction. The lesson was clear. The universe could mimic intention without requiring design. Nature was capable of writing patterns that seemed artificial, and those patterns could mislead even the most disciplined minds. This caution became a defining tone in the years that followed. Each new signal, each unexplained burst or anomaly, was weighed against the sobering memory of pulsars. Perhaps it was natural, perhaps it was interference, perhaps it was something entirely new. But to leap too quickly to alien explanations would risk both credibility and clarity. Scientists became guardians not just of data, but of restraint, walking a narrow line between curiosity and skepticism. Yet the cultural moment could not be so easily contained. Outside laboratories, the possibility of signals from other worlds ignited the imagination of the public. The late 1960s were years of tension and wonder. The Cold War stretched its shadow across the globe. While the Apollo program carried humans to the moon, the idea that alien civilizations might already be whispering into the cosmic dark resonated with both hope and fear. Were these signals evidence of cosmic neighbors or the shadows of enemy? Technologies cloaked in the sky, governments steeped in secrecy, monitored space not only for natural mysteries, but for the possibility of hidden weapons, covert experiments, and satellite transmissions. The paranoia of the age shaped the way signals were received. Anything unexplained was treated with suspicion. Any anomaly tested against the backdrop of geopolitical rivalry, and yet, even in that atmosphere of distrust, a new movement began to emerge, one that dared to take seriously the idea of listening for other minds. The search for extraterrestrial intelligence, or SETI, was born not from fantasy but from the recognition that the cosmos was filled with signals. Pulsars had shown that new classes of objects could be uncovered through listening. Quasars had demonstrated the power of unseen energy sources. The cosmic microwave background had whispered of the universe's origin. If such wonders could be revealed, why not also the voices of civilizations? SETI began modestly, with small projects, borrowed telescope time, and limited funding. In 1960, Frank Drake conducted Project Ozma, the first modern attempt to listen deliberately for signals from other civilizations. Pointing a radio telescope in West Virginia toward nearby stars Tau Ceti and Epsilon Eridani, he searched for narrowband transmissions, signals that nature itself would be unlikely to produce. None were found, but the experiment seeded a field that would endure for decades. The creation of the Drake equation soon followed, a framework to estimate the number of civilizations that might exist in the galaxy. It was a reminder that the question of signals was not only scientific but philosophical. How common is life? How rare is intelligence? And how fragile is communication across the abyss of time? Each term in the equation was uncertain, each variable a mirror of human ignorance. And yet, the very act of writing it down gave structure to the dream of contact. Still, skepticism held firm. Within the scientific community, to invoke alien intelligence was to walk a perilous line. The Pulsar episode had underscored the danger of premature conclusions. Funding agencies were wary of speculation, preferring tangible astrophysics to what they regarded as the fringes of science. And yet, the mystery of unexplained signals lingered at the edges of credibility, drawing both caution and quiet fascination. The fragility of human hope was laid bare in this tension. To listen was to risk disappointment. To interpret every anomaly as natural was to risk missing the extraordinary. Between those poles, science moved carefully, like a tightrope stretched across a chasm. Humanity's deepest longing to know it is not alone was balanced against its deepest fear, to mistake noise for meaning, and in doing so, to reveal its own desperation. As the years passed, the pattern repeated itself. Signals were found, studied, explained, and absorbed into the expanding map of natural phenomena. Yet always, a few remained unexplained anomalies, like faint embers smouldering at the edge of understanding. Each one reignited the question: could this be a voice, or merely another trick of nature? The answer was never final, only deferred. In those years, the act of listening itself became a kind of philosophy. To aim a telescope into the void was not only to collect data, but to practice humility, to acknowledge that humanity's place in the universe was not central, that meaning might exist far beyond the reach of its own small world. The signals, whether natural or artificial, carried a weight that transcended science. They were reminders that the cosmos was alive, dynamic, and capable of speaking in ways both familiar and utterly alien. And so, the first reactions to mysterious signals settled into a paradoxical state: cautious skepticism, tempered by wonder. The pulsars had proven that nature could surprise in ways that mimicked design, and the Cold War had reminded humanity that fear could cloud perception. Yet SETI had shown that the search itself was not folly, but a natural extension of scientific curiosity. The universe had revealed itself to be a place of rhythms and bursts, of coded patterns and fleeting voices. Whether those voices were born of collapsing stars or distant civilizations, they had already transformed the way humanity understood its place in the dark. The world of science stood at a threshold it had never crossed before. On one hand lay the rigor of skepticism, the demand for verifiable evidence and repeatable experiments. In the other lay the undeniable pull of wonder, the recognition that some signals arrived carrying the flavor of design, as though intention itself might be woven into the noise. This tension defined the earliest years of reaction, when the first pulsars were revealed as the corpses of massive stars, spinning with the relentlessness of a cosmic machine. A wave of relief rippled through the scientific community. The specter of declaring alien contact prematurely had been avoided. Yet beneath that relief lingered a subtle melancholy. For a moment, the human imagination had soared to the possibility of minds beyond Earth, only to return again to the cold comfort of natural explanation. The signals remained extraordinary, but their extraordinariness belonged to physics, not to intelligence. It was a humbling reminder that nature was not only more creative than humankind expected, but also more deceptive. In the cultural backdrop of the 1960s, this restraint carried heavy meaning. Humanity was reaching outward with rockets and spacecraft, touching the moon, sending probes toward distant planets, and dreaming of futures beyond Earth. In such an age, the prospect of alien voices arriving unbidden from the void seemed almost plausible. Yet the same decade was defined by suspicion and secrecy. The Cold War turned the heavens into another battleground of paranoia, where every unexplained signal risked being misread as an enemy experiment, a covert satellite, or a technological weapon hidden in plain sight. Governments were cautious, wary of allowing speculation to ignite fears they could not control. In that atmosphere, The scientific community's insistence on patience and verification was not merely intellectual discipline, it was a shield against chaos in a world already balanced on the edge of nuclear uncertainty. Still, the idea of listening did not fade. The discovery of pulsars, though natural, proved something profound. The universe was filled with rhythms that could only be uncovered by pressing an ear against the stars. If one class of signal had been waiting to be heard, why not others? This line of thought crystallized into the birth of SETI, the search for extraterrestrial intelligence. The early efforts were small and tentative, almost fragile in their scope, but they were anchored in a bold assumption that if civilizations existed elsewhere, they too might send their voices into the dark. Frank Drake's Project Ozma in 1960 embodied this idea, targeting nearby stars with the hope of catching a narrowband transmission, a signal so pure in its frequency that nature could not easily account for it. The silence that followed did not discourage the effort. Instead, it became part of the philosophy. If the sky was quiet, perhaps it was only because humanity had not yet learned to listen properly, or had not yet looked in the right direction. What emerged in these years was more than a new branch of science. It was a reflection of the human condition itself, of the longing for connection and the fragility of hope when stretched across cosmic scales. Every unexplained signal carried the potential to answer the oldest of questions. Are we alone? And yet, with each natural explanation, the answer dissolved back into silence, reminding humanity that its desire for company could not dictate the universe's truths. To listen was to live in constant suspension between awe and skepticism, between hope and humility. This balance defined the first reactions to the mysterious signals. The scientific community could not afford the recklessness of premature declarations, yet it also could not ignore the possibility that the next anomaly might be something more. And so, the discipline of listening grew into a practice of patience, an act of watching the horizon of the unknown, aware that most lights are stars, but daring to wonder whether one might someday be a lantern lit by another intelligence. In that fragile equilibrium, science and philosophy merged. For every signal, whether a pulsar's heartbeat or an unexplained burst of static, asked the same question: what does it mean to listen for voices in the dark, knowing that silence may be the only reply? By the late 1970s, radio astronomy had matured into a patient discipline, its instruments scattered across mountaintops and plains, each dish trained toward the skies with a single purpose: to listen. Among these was the Big Ear Radio Observatory in Ohio, a sprawling metal structure that resembled less a telescope than a vast, skeletal ear pressed against the heavens. It was here, on the night of August 15th, 1977, that one of the most enduring enigmas in the search for cosmic signals arrived, a burst of radio energy so sharp, so deliberate in appearance, that even decades later it would remain unforgotten. The event lasted for precisely 72 seconds, the maximum length the telescope could dwell on a single patch of sky as the Earth rotated beneath it. In that narrow window, the receiver detected a signal at a frequency of 1420 MHz, the spectral line of neutral hydrogen, a frequency that many scientists had theorized would be the most logical beacon for any extraterrestrial civilization to choose, as it represents the fundamental element of the universe. The signal was strong, 30 times the background noise, and it rose and fell exactly as one would expect from a source drifting with the telescope's motion. It carried no signature of terrestrial interference, no echo of passing aircraft, no correlation with known satellites, It appeared once, then vanished forever. When the astronomer Jerry Eman examined the computer printout days later, he was so struck by the signal's clarity that he circled it in red ink and scrawled a single word beside it: wow. It was not a scientific conclusion, nor a declaration of discovery. It was an unfiltered human reaction, the exclamation of someone who, for a fleeting instant, felt he might be looking at the very evidence humanity had been seeking. The name endured, attaching itself to the anomaly as though the cosmos had whispered back, not with an explanation, but with a question mark. The following months brought a cascade of scrutiny. Every possible earthly explanation was tested. Could the signal have come from a military transmission, a classified satellite, or a terrestrial reflection of some nearby broadcast? Each possibility was investigated and discarded. The telescope had to feed horns capable of distinguishing between sources. Only one recorded the event, as would be expected for a signal arriving from deep space. If it were Earth-based interference, both horns would likely have detected it. The checks yielded no culprit. The source region, near the constellation Sagittarius, was rescanned again and again in the months and years that followed. Yet the cosmos remained quiet, as if whatever voice had spoken had already retreated into silence. Wow. Signal stood alone, a monolith of ambiguity. It was neither confirmed nor explained away. For the scientific community, it became both a symbol of possibility and a cautionary tale. Possibility, because it showed that the universe could still surprise even the most careful of searchers. A cautionary tale, because without repetition, without independent verification, science could not call it evidence of anything more than an anomaly. In the years that followed, the balance tilted towards skepticism, as more sensitive instruments expanded their reach and yet failed to find its like again. But wow. Signal was not the only whisper that teased researchers in those years. Across observatories, faint irregularities were logged, catalogued, and dismissed. Most revealed themselves in time as prosaic origins, the steady beacon of pulsars, once thought alien, now catalogued as the spinning corpses of massive stars. Quasars, whose ferocious light was fueled by supermassive black holes, and the ever-present contamination of human technology leaking signals into the sky. The more data was collected, the more it seemed that nature was adept at creating phenomena that mimicked intentional design. The night sky, when heard through the medium of radio waves, was not silent, but it was rarely orderly. Yet anomalies persisted. They were not abundant, not repeatable, but scattered like mirages along the desert. Horizon, a sudden spike here, a curious pattern there. For every 1,000 signals discarded as noise, 1 or 2 defied neat categorization. Scientists combed through oceans of static, running streams of numbers through computers, searching for patterns that might repeat, rhythms that might speak of intent. Entire careers were devoted to this patient act of listening, of differentiating the whisper of a star's death from the imagined murmur of intelligence. The act was both technical and philosophical. Technical in the sense that it required algorithms, filters, and statistical rigor. Philosophical in that it forced humanity to stare at its own longing reflected in the cosmos. SETI's programs in those early decades were modest in their reach but vast in their ambition. Narrow frequency bands were monitored, chosen for their symbolic universality, such as the hydrogen line. Stars like Tau Ceti and Epsilon Eridani, once thought potential hosts of planets, were among the first targets. But time and again, the results came back empty. The silence was not absolute. The instruments were filled with signals, but none bore the fingerprints of something intentional. Each disappointment pressed the question: if civilizations were out there, why were they not speaking, or why were their voices not reaching us? Skepticism deepened with every natural explanation found. The pulsar had been a lesson in humility. What appeared artificial at first glance turned out to be a window into one of nature's most extreme creations. It was a warning that extraordinary phenomena need not imply extraordinary intent. The scientific method demanded that the bar for claiming contact with another intelligence be set impossibly high, higher than for almost any other discovery. Without repeatability, without independent verification, anomalies remained curiosities, rather than revelations. And yet, despite this sobering reality, the question refused to die. The unresolved anomalies, the wow signal most of all, lingered in the background like a haunting melody that could not be forgotten. The human mind is not content with silence. It strains against it, reaching for meaning in the noise. Wow signal became not just a data point, but a cultural symbol, invoked in conversations about extraterrestrial life, depicted in films and books, a reminder that perhaps the universe had once, if only for 72 seconds, called back. It is in the nature of science to demand caution, but it is in the nature of humanity to dream. The early investigations of cosmic signals embodied both instincts. They revealed a universe alive with natural rhythms, yet capable of producing events that resist explanation. They demanded humility in the face of false hope, but they left just enough room for wonder to persist. The scientists who combed through those oceans of static did more than sift data. They performed a kind of cosmic vigil, standing watch at the edge of the unknown, waiting for the night to whisper again. For in those early decades, one truth became clear: silence itself is a form of mystery. The absence of signals does not resolve the question, but deepens it. If the universe is quiet, then perhaps intelligence is rare. Perhaps civilizations are fragile. Perhaps the distances between them are so great that even light cannot bridge the gulf. Or perhaps the voices are there, but speaking in forms we cannot yet recognize, in frequencies outside our grasp, in languages beyond our comprehension.
Wow.
Signals stood as both a gift and a riddle, a fleeting reminder that the cosmos may not be mute, only patient. And so the search continued, even as skepticism grew. The early investigations taught restraint, but they did not extinguish hope. For every natural explanation offered, for every disappointment catalogued, there remained the possibility, faint but undeniable, that one of these anomalies was not a trick of physics, not a glitch in machinery, but the first syllable of a conversation waiting to unfold. Humanity stood ready to listen, even if it meant waiting across lifetimes, even if it meant listening through the silence of ages. The act of searching became, in time, less about discovery and more about endurance. Astronomers found themselves drowning in data, mountains of printouts and endless streams of digital records that mapped the universe in hisses and bursts. To the untrained eye, these sheets were chaos, mere noise without melody. But to those who spent their lives immersed in it, there was always the possibility that a single anomaly might emerge, a whisper hidden in the static, a pulse just sharp enough to hint at order. They sifted with the devotion of monks copying manuscripts, patient, disciplined, aware that entire careers might pass without the reward of certainty. Yet still they searched, because the possibility of finding a voice in the dark outweighed the futility of silence. Computer algorithms became indispensable companions in this vigil. As telescopes grew more powerful, they generated torrents of information far beyond the ability of human eyes to pass. Software combed the data for narrowband frequencies, for sudden spikes, for signals that drifted in ways natural sources could not explain. But the computers could not interpret meaning. They could only flag the unusual. It was left to human judgment to decide whether the unusual was worth pursuing, whether the anomaly carried weight or was merely the echo of interference. Again and again, most suspects collapsed under scrutiny. The patterns are resolved into satellites, into microwave ovens left running near observatories, into reflections of Earth's own chatter bouncing off the atmosphere. Each elimination was necessary, but it chipped away at hope, leaving researchers to wonder whether the silence they endured was genuine or merely self-inflicted, buried beneath the noise of their own civilization. Still, anomalies like the WOW signal refused to vanish from memory. They occupied a peculiar space in scientific culture, neither embraced nor discarded, suspended between possibility and irrelevance. For some, they represented a reminder of humility, that extraordinary claims must forever be held at a distance until they withstand the harshest scrutiny. For others, they were an inspiration, evidence that even a fleeting anomaly could sustain decades of curiosity, keeping alive the dream that the universe might yet harbor intelligence beyond Earth. It was a paradox. A single, unrepeatable event had no scientific weight, yet it carried enormous symbolic power. It kept the ears of humanity pressed to the heavens, unwilling to stop listening. The psychological strain of this work was profound. To search for voices across the stars is to embrace disappointment as a daily companion. Scientists knew the odds, knew that silence was far more likely than contact. Yet their work demanded a kind of faith, not faith in the certainty of discovery, but in the worthiness of the search itself. Each night of data collection was a vigil against loneliness on a cosmic scale. Each anomaly, no matter how faint, became a flicker of possibility, a reason to continue. WOW signal embodied this tension perfectly, a reminder that sometimes the universe speaks only once, and that one must decide whether that whisper is enough to keep believing. As decades passed, SETI grew more systematic, expanding its reach across the sky with new telescopes and broader frequency ranges. The technology improved, but the philosophy deepened as well. WOW signal had taught that the cosmos does not yield its secrets easily. It may offer glimpses, hints, but it demands patience, bordering on reverence. The silence of the universe became not a discouragement, but a mystery in its own right. Why should a universe so vast remain so quiet? Was intelligence truly rare, a fleeting spark in the dark? Or was humanity simply listening in the wrong way, attuned to frequencies that no one else used, searching for voices that spoke in an entirely different tongue? These questions were not failures of science, but extensions of it, pulling researchers into philosophy as much as physics. In this way, the early investigations were not just about signals, but about humanity's place in the cosmos. Each burst of static, each fleeting anomaly, forced reflection on what it meant to seek companionship across the stars. The work demanded humility, for the universe consistently revealed that what seemed alien at first was often a deeper layer of nature's design. Yet it also demanded audacity, for to keep listening against silence is an act of defiance, a refusal to accept isolation without proof. And so, through the balance of skepticism and wonder, through the long nights of listening to nothing at all, a philosophy took root that even if the universe remained silent, the search itself was a way of answering, In 2007, the silence of the cosmos fractured once again. Buried deep in archival data from the Parkes Radio Telescope in Australia, astronomers found something extraordinary, a burst of radio energy so powerful, so brief, that it defied all expectations. It lasted less than a few milliseconds, shorter than the blink of an eye, yet in that instant it unleashed as much energy as the sun emits in days, perhaps even weeks. Its origin was far beyond the Milky Way, at distances so vast that its signal had traveled billions of years before arriving at Earth. It was the first of what would come to be known as fast radio bursts, or FRBs, a phenomenon unlike anything radio astronomy had ever encountered. The discovery arrived almost by accident. Duncan Lorimer and his team were combing through old observations, searching for pulsars, when they stumbled upon the event. At first it seemed impossible. A signal of such intensity, compressed into such a fleeting moment, should not have been detectable across such immense distances. Yet the data was undeniable. Nature, it seemed, had found a way to channel cosmic power into a whisper sharp enough to pierce the universe and reach across billions of light years. In the beginning, many wondered if it was a fluke, perhaps an error in the telescope, a glitch of instrumentation masquerading as mystery. But soon enough, other bursts were found. Different observatories confirmed them. They were real and they were unlike anything seen before. For years, only a handful of FRBs were catalogued. Each one arrived unannounced, never to be heard again from the same location. They were maddening in their elusiveness, so bright, so violent, and yet so brief that no telescope could react in time. They came without warning, like flashes of lightning behind a distant horizon, illuminating the darkness only to vanish before their shape could be studied. Astronomers were left with fragments, the time, the frequency, the intensity, but no context, no repeating pattern, no clue as to their engines. The universe had spoken, but only in syllables too short to understand. Then, in 2012, everything changed. A repeating burst was discovered. For the first time, a source flared more than once, offering astronomers a chance to watch the phenomenon unfold rather than merely recording its echo. This repeater was a revelation. It suggested that not all FRBs were the product of one-time cataclysms, such as the collapse of stars or the merging of compact objects. Some appeared capable of producing bursts again and again, like a heartbeat buried in the static of the cosmos. The implications were staggering. Either multiple mechanisms were at work, some cataclysmic, others persistent, or the universe was orchestrating an astrophysical process so complex it defied easy categorization. As new telescopes came online, the mystery deepened. Instruments like CHIME in Canada, with its sweeping array of cylinders scanning the sky each night, transformed the search. Where once only a handful of FRBs had been recorded in years, CHIME began detecting them almost daily, uncovering dozens, then hundreds, then thousands. Some repeated, most did not. Some carried peculiar structures within their signals, subbursts and fine details that hinted at processes even stranger than their already baffling existence. A few arrived with rhythmic regularity, repeating at intervals as though governed by some cosmic metronome. Others seemed entirely chaotic, unpredictable in every respect. The distances involved only amplified the enigma. Many FRBs originated from galaxies billions of light-years away, meaning they had been traveling since before the Earth even formed, their messages arriving long after their source might have ceased to exist. to shine so brightly across such distances required energies beyond almost anything else known in the cosmos. If neutron stars were involved, their magnetic fields must be pushed to extremes scarcely imagined. If black holes were responsible, the processes must channel their fury into narrow beams that just happened to sweep across Earth. Each possibility strained at the limits of known physics, and still, some could not help but wonder if intelligence might play a role. The sharpness of the bursts, the precision of their frequencies, the peculiarities of their repetition. These qualities whispered of design, even as mainstream science leaned toward natural explanations. Few were willing to stake their reputation on such speculation, yet the thought lingered, unspoken in the margins of conference halls and late-night discussions. What if these were not merely cosmic explosions, but transmissions, intentional or otherwise, leaking across time and space? If so, what kind of civilization could command energies greater than galaxies, packaged into moments shorter than a breath? The more FRBs were studied, the less clear their origins became. Some bore the fingerprints of magnetars, the hypermagnetic, remnants of massive stars whose fields could tear atoms apart. Others did not fit so neatly, hinting at engines still unimagined. The variety was itself a mystery. Why should some repeat and others not? Why should some arrive with clear structure and others as singular blasts? Was the universe offering multiple answers, or was humanity still failing to see the whole picture? Each new observation only expanded the spectrum of mystery. FRBs became not a puzzle to be solved, but a window into a landscape of possibilities. They were at once familiar and alien, grounded in physics, yet suggestive of phenomena beyond current understanding. They resisted reduction, demanded humility, and invited speculation. For scientists, they represented the cutting edge of astrophysics, the frontier where known laws bent toward the unknown. For humanity at large, they symbolized something deeper, that the universe still held secrets capable of startling even the most advanced instruments, that there remained mysteries vast enough to remind us how little we truly understood. In the span of just over a decade, FRBs transformed from a curiosity into one of the most tantalizing enigmas in modern science. They were no longer isolated whispers, but a chorus, scattered across the cosmos, each one carrying the weight of energy beyond comprehension. Whether the product of extreme astrophysical processes or something stranger still, they reminded humanity of the power of listening. For within each millisecond burst lay not only the echo of distant galaxies, but the possibility of entirely new chapters in the story of the universe. And so the vigil continued. Telescopes scanned the skies with ever greater sensitivity. Software combed the floods of data for anomalies. And researchers debated theories that stretched from the edges of physics to the edges of imagination. The silence of space had fractured, but it had not spoken clearly. Instead, it offered fragments, bursts, and riddles. FRBs had become the new frontier, the mysterious signals that refused to be explained, that hovered between natural and unimaginable, that drew humanity deeper into the abyss of its own questions. For in every burst there was more than energy. There was a message, not in words, but in the reminder that the universe is still alive with mysteries waiting to be heard. The first great breakthrough came with FRB 121102, the original repeater. Discovered in 2012 and later studied with telescopes around the world, it became the first source to prove that some fast radio bursts were not singular, one-time events, but could flash again and again. Unlike the wow, the signal which vanished. Forever into silence, FRB-1 returned, dozens, then hundreds of times. Its bursts were unpredictable, but each arrival allowed scientists to peel back a little more of the enigma. Using the immense power of the Arecibo Observatory in Puerto Rico and later the Very Large Array in New Mexico, astronomers traced it to a dwarf galaxy more than 3 billion light-years away. There, it seemed nestled in a region dense with star formation, bathed in magnetic chaos. It was not a definitive answer, but it was a foothold. Magnetar's young neutron stars, wrapped in magnetic fields, trillions of times stronger than Earth's, became the leading candidates. Such objects were violent enough, unstable enough, to generate bursts of that magnitude. Yet even this theory did not fully explain the peculiarities of FRB 121,102, including its strange polarization and extreme magnetic environment. The repeater had not solved the mystery, it had deepened it. Then came FRB 180,916, a discovery that challenged expectations even further. Unlike the chaotic rhythms of 121,102, this burst carried a pattern. It repeated every 16 days, a rhythm as if the universe itself were keeping time. To detect such regularity was staggering. It suggested not randomness, but structure, something governed by cycles or orbital mechanics. Some speculated that it could be the product of a neutron star orbiting a massive companion, its bursts triggered only when conditions aligned. Others entertained the notion of entirely new astrophysical processes. But in the undercurrent of imagination, the periodicity stirred something deeper. What if regularity itself was a clue, the trace of intention? Mainstream science did not linger on this thought, but the cultural imagination seized it. A repeating cosmic pulse, echoing every 16 days across 500 million light-years, resonated like the heartbeat of the unknown. As more repeaters were found, it became clear that FRBs were not a single phenomenon. Some flared once and were never heard again. Others repeated sporadically, without pattern. A few revealed intricate substructures, microsecond variations that hinted at incredibly compact sources. CHIME, with its sweeping daily survey of the northern sky, multiplied the catalogue at unprecedented speed, detecting hundreds of bursts in a single year. What had once been a handful of strange anomalies was now an entire category of astrophysical events, diverse and bewildering. The flood of data brought both clarity and confusion. FRBs were undeniably real, undeniably widespread, yet their origins remained unsettled. They were too bright, too fast, too powerful, and too varied to be pinned neatly into one explanation in time. Scientists began to see FRBs not as a puzzle with a single answer, but as a spectrum of mysteries. Some were likely born from cataclysms, the collapse of massive stars, the merging of neutron stars, the tearing of space-time in the grip of black holes. Others seemed tied to persistent engines like magnetars, whose restless fields could snap and release unimaginable energy. And still, some resisted every natural explanation. Their qualities too peculiar, their rhythms too suggestive of something outside the expected. It was here, in this tension between the natural and the unknown, that FRBs became not just an astrophysical enigma, but a philosophical one. The implications stretched beyond astronomy. If FRBs were purely natural, then they opened the door to new physics, to energies and mechanisms not yet understood. If even a fraction were artificial, the faintest possibility of intelligence, then the consequences would ripple through every dimension of human thought. Scientists remained cautious, tethered to evidence, aware that extraordinary claims demanded extraordinary proof. Yet the public imagination, less bound by caution, saw in FRBs a tantalizing echo of contact, the possibility that somewhere in the abyss, civilizations wielding energies beyond comprehension might be speaking. Even if humanity lacked the language to translate, the story of FRBs was, and remains, one of awe, balanced by humility. Each detection is a fragment, a sliver of information carried across cosmic distances. Alone, each burst is incomplete, a syllable without a sentence. Together, they form a growing chorus, still incomprehensible, but too insistent to ignore. The sky is alive with these signals, arriving daily, their diversity mocking human attempts at categorization. They are reminders that the universe is not static, not silent, but restless and dynamic, filled with phenomena that challenge even the most powerful theories. And they carry with them a lesson that echoes through the history of astronomy, that every time humanity believes it has grasped the limits of nature, the cosmos unveils something stranger still. Under the patient gaze of the world's great radio telescopes, the mystery did not dissolve, it thickened. For every signal that repeated, offering scientists the chance to probe and measure, there were dozens more that flashed once and were gone forever. A single, brilliant burst, carrying more energy in a fraction of a second than the sun emits in days, would arrive unannounced, and then the cosmos would close its fist around the secret. No second chance, no confirmation, just a single echo. In the static, impossible to verify, impossible to dismiss. These one-off bursts became both a gift and a curse, a tantalizing reminder of cosmic phenomena beyond comprehension, and a relentless source of frustration for those who tried to pin them down. Without repetition, a burst is an enigma without a signature, an apparition glimpsed in a storm, its nature locked behind the silence that follows. In this silence, speculation grew. Magnetars remained the leading suspects, their immense magnetic fields capable of twisting and snapping with titanic force, releasing bursts of energy that could cross the void. The discovery of a powerful radio flash from a magnetar in our own galaxy in 2020 gave weight to the theory, proving that such objects could indeed produce bursts resembling FRBs. Yet even this connection was incomplete. Galactic magnetar, Flatus, fell short of explaining the full diversity of FRBs, especially those arriving from billions of light-years away with powers magnitudes greater than anything local space had revealed. Magnetars could explain some, but not all. Other theories emerged, each carrying the scent of the extraordinary. Some imagined neutron stars colliding or black holes feeding on companion stars, cataclysms that would unleash unimaginable violence. Others looked deeper into the fabric of physics itself, two concepts unproven but mathematically plausible. Cosmic strings, hypothetical remnants from the earliest moments of the universe, could snap like taut wires, stretched across space-time, releasing bursts of pure energy, or perhaps cracks in space-time itself, brief ruptures where the laws of reality, bent under stress, could produce such fleeting explosions. These ideas, though speculative, revealed the scope of the mystery. FRBs were not only a puzzle of astrophysics, but a possible keyhole into the deeper architecture of the cosmos. Yet amidst the wildness of theory, hints of structure began to appear. A handful of repeating FRBs revealed peculiar rhythms, cycles that suggested more than chaos. Bursts arriving in clustered patterns, others following strange periodicities, as if there were hidden metronomes beating behind the veil of noise. Most scientists interpreted these patterns through natural astrophysical mechanisms, orbital interactions, precessing neutron stars, or magnetar environments modulating the signals. But the human imagination lingered on the possibility of intention. Rhythms suggested design, and design suggested intelligence. It was not proof, nor even evidence, but it was enough to keep the question alive. For every new discovery, the boundary between the known and the unknown seemed to shift. The natural explanations grew more sophisticated, the data more abundant, but the core enigma refused to yield. FRBs were too fast, too bright, too numerous, and too varied to fit neatly into a single framework. Each new detection was like a piece from a puzzle whose image only grew stranger with each addition. The deeper scientists looked, the more the mystery expanded, as if the universe were not offering an answer, but instead inviting humanity into a dialogue, one conducted in pulses of radio light across billions of years. In this dialogue, the emotional undertone was impossible to ignore. To listen for FRBs was not merely to study astrophysics. It was to eavesdrop on the cosmos, to catch fragments of a conversation whose meaning remained veiled. Were these signals the cries of collapsing stars, the whispers of magnetic titans, or the trembling of space-time itself? Or were they something entirely outside the current map of possibility? Each possibility carried weight, not only for science, but for humanity's place within the universe. If natural, they expanded the horizons of physics, demanding new models and deeper understanding. If artificial, they would mean that across the gulf of darkness, other minds had risen, capable of wielding the forces of galaxies as casually as humans spark a match. The truth remains suspended, waiting. What is clear is that with FRBs, humanity has stumbled upon a phenomenon vast, powerful, and not yet understood. They arrive without warning, without pattern, as if the universe is reminding us of its immensity and unpredictability. Every detection is a small window, a fleeting glimpse into a hidden order, and with each one, the sense grows stronger that these are not just astronomical curiosities, but messages, whether from stars, from space-time, or from something else entirely. They are the murmurs of a universe still writing its story, still withholding its deepest chapters. The arrival of new instruments transformed the mystery from an occasional anomaly into a torrent of signals. Where once radio astronomers might wait months or even years for a single unexplained burst. The Canadian Hydrogen Intensity Mapping Experiment, CHIME, began detecting them almost daily. This sprawling array of curved cylinders, resting in the quiet valleys of British Columbia, opened its ears to the sky and was immediately flooded with whispers. Hundreds of FRBs arriving from every direction, each with its own peculiar traits. Some blazed once and fell silent, others returned with rhythms, like a cosmic heartbeat fading in and out of perception. With every new dataset, the mystery became less about whether FRBs were real and more about what they truly meant. The flood of signals was both exhilarating and disorienting. It was as if humanity had cracked open a door it was not yet prepared to walk through, and yet more data did not always bring clarity. Instead, it revealed layers of complexity that deepened the puzzle. Patterns began to emerge in the dispersion of the signals, subtle distortions caused by their passage through intergalactic plasma. Each FRB carried with it a record of the cosmic journey it had endured, a kind of fingerprint of the matter that lay between its source and Earth. By decoding these distortions, Astronomers realized they could map the otherwise invisible web of gas and plasma that threads the universe together. FRBs, then, were not only mysteries in themselves. They became tools, probes, capable of tracing the unseen scaffolding of the cosmos. But even as their utility grew, the question of origin remained unanswered. Tools or not, the bursts still spoke with a voice no one could yet interpret. The strangeness grew sharper with each anomalous case. One repeating FRB seemed to follow a cycle of 90 days on, 60 days off, like a lighthouse turning its beam across a dark ocean. Another sent out bursts that changed in pitch and strength, hinting at intricate physical processes or perhaps structured signals. A handful of bursts showed polarization patterns so extreme that they defied known astrophysical mechanisms, as if the radio waves themselves had been twisted and reshaped by forces unseen. Each new wrinkle challenged the existing models. Magnetars still held sway as the leading explanation, but the sheer variety of FRBs suggested that no single theory could account for them all. The universe seemed to be telling many stories at once, and humanity had only just begun to learn its alphabet. There was also the persistent weight of human imagination. Whenever rhythms or periodicities were detected, whispers of artificial origin resurfaced. The scientific community, careful to avoid premature conclusions, remained grounded in natural explanations, yet the undertone of possibility could not be erased. History had shown that pulsars too were once thought to be alien beacons, only later revealed as neutron stars. Might FRBs follow a similar path, dazzling at first, mysterious, but eventually tamed by physics? Or might they resist explanation longer, pulling science toward new horizons of understanding? The tension between skepticism and wonder defined every debate, every paper, every late-night conversation between researchers staring at data that shimmered like riddles. What was undeniable was the sense of opening, a widening of the horizon. For centuries, the universe had revealed itself primarily through light, the stars and galaxies visible across the spectrum. Now it was speaking in pulses, in signals sharper and stranger than anything imagined. Each FRB was a flare shot across billions of years, carrying secrets of its birth and the medium through which it traveled. The fact that they could be detected at all, given their brevity, was remarkable in itself. It was like catching a single drop of rain in a desert storm, and yet with instruments like CHIME, Parkes, and Meerkat, those drops became torrents, each one a message in a language still beyond translation. The mystery, instead of shrinking, expanded. The more humanity listened, the louder the chorus became, and yet the words remained veiled. Were these the cries of collapsing stars, the lightning of magnetic giants, or the trembling of space-time itself? Each explanation seemed to brush against the truth without fully capturing it. The bursts were too varied, too widespread, too elusive. They were fragments of a hidden order, glimpses of something vast, possibly ancient, and almost certainly beyond the immediate grasp of human understanding. And so, the story of FRBs remained suspended between knowledge and wonder. Instruments grew sharper, data multiplied, and theories evolved. But the essence of the enigma endured. Brief flashes of impossible energy, scattered across the cosmos, arriving like whispers in the silence of night. The more humanity listened, the more it realized that the universe was not silent at all. It was speaking constantly, urgently, and in ways that revealed how much still lay hidden. The bursts became reminders of humility, evidence that even in an age of satellites and space probes, the cosmos could still astonish with mysteries that defied comprehension. They were, and remain, invitations to listen longer, to think deeper, and to accept that some questions will not yield easily, if ever, to answers. In the search for mysterious signals, the limits of human ingenuity are tested as much as the patience of the cosmos. To catch a whisper from billions of light years away, instruments must be sharpened to an almost impossible edge. FRBs often last less than a millisecond, a fleeting instant that would vanish unnoticed without detectors, tuned to the finest slivers of time. The challenge is staggering. To build machines that can not only hear these brief flashes, but distinguish them from the ceaseless thunder of human-made interference and natural cosmic noise. Every antenna, every sensor, every circuit becomes a kind of ear pressed against infinity, straining to catch what might otherwise be lost forever. The volume of data is beyond anything the early radio astronomers could have imagined. CHIME alone produces petabytes of raw information each day, a torrent of signals more vast than the sum of all the words spoken by humanity in centuries. Into this flood, artificial intelligence has been set loose, trained to detect patterns, invisible to human eyes, to sift anomalies from oceans of static. Algorithms race through the noise like silent divers, searching for pearls buried in the abyss. Without these tools, the majority of FRBs would remain hidden, drowned by the enormity of the cosmos and the fragility of human perception. Technology becomes not only an extension of human senses, but a redefinition of what it means to listen. And yet, even with such precision, the mystery refuses to yield. Each FRB detected is a reminder of what is missed bursts that may fall. Outside the ranges humans monitor, signals that might encode information in ways that human minds cannot yet conceive. The danger of anthropocentrism lingers, the assumption that any intelligence beyond Earth would communicate as humans do, with repetition, with structured codes, with mathematical signatures chosen for clarity. But perhaps other minds, if they exist, would use modes of expression far beyond human categories, their signals woven in frequencies too subtle or too strange to register as meaningful. The cosmos could be alive with conversation, yet humanity may be deaf to its true language. This possibility haunts every search. It is not merely a matter of building larger telescopes or refining algorithms, but of reshaping thought itself. The act of listening becomes philosophical, forcing science to confront the limits of perception and the biases carried into the stars. What if the signals are constant, flowing all around, yet only fragments fall into the narrow keyholes humanity has chosen to watch? What if the most profound conversations of the universe are written in tones the human ear has never learned to hear? And still, each detection, however fleeting, pushes the frontier of understanding forward. FRBs have forced physics to confront extremes of matter, energy, and space-time. They demand instruments of unprecedented sensitivity, data systems of almost unimaginable power, and collaborations spanning continents. They stretch not only technology but imagination, reminding humanity that the cosmos will not reveal itself easily. To chase these bursts is to accept that every answer will generate more questions, every explanation will lead deeper into mystery. The signals arrive, brilliant and brief, not to resolve but to provoke, as if the universe itself is testing the patience and humility of those who listen. The edge of science is not a destination, but a horizon that recedes with every step forward. In pursuing FRBs, humanity is not merely building machines or decoding data, it is learning to stretch its imagination, to accept that reality is wider, stranger, and more intricate than any one generation can comprehend. Each microsecond burst is a fragment of that wider truth, a reminder that listening to the cosmos is not about final answers, but about opening the mind to questions as vast as the sky itself. The arms of discovery stretch wider still, for the hunt for these signals has become a dialogue not just between astronomers and their machines, but between humanity and the scale of the cosmos itself. To listen for microsecond bursts requires not only precision but humility, the acknowledgement that most of what exists remains unseen, unheard, unrecorded. Every radio telescope on Earth, no matter how vast, is still only a pinhole through which to glimpse infinity. The sky, immense and unyielding, speaks in a million voices at once, and human instruments catch only fragments, as though overhearing one word torn from a library of endless books. The immensity of what is missed weighs heavily on the scientific imagination. Perhaps every star in the night sky has cried out, but humanity has been deaf to their song. It is here that the limits of technology collide with the limits of thought. Supercomputers, no matter how powerful, remain bound by the frameworks of human design. Artificial intelligence, however advanced, still reflects the assumptions of its creators, filtering data for the kinds of signals humans expect to find. And yet, what if the cosmos speaks in patterns that resemble no human mathematics, rhythms that slip through the nets woven by code? What if FRBs are not anomalies, but only the faintest tips of a spectrum of signals coursing constantly through space, hidden from view by the narrowness of perception? In such moments of reflection, the pursuit becomes less about catching every burst, and more about questioning what it even means to listen. This is where the mystery begins to dissolve into philosophy. The notion of signal and noise, so clear in engineering, becomes murky in the cosmos. What is noise when the universe itself is the transmitter? What is the signal when the categories of human recognition may exclude entire dimensions of meaning? The history of science is filled with discoveries first dismissed as interference. The cosmic microwave background, for instance, was nearly overlooked as the residue of bird droppings on a radio antenna. Could something of equal magnitude now be hidden within the oceans of FRB data, overlooked because its signature does not align with expectation? The danger is not silence, but blindness. And yet, the pursuit continues with a sense of awe that transcends frustration. To detect even a single burst, to confirm even one fleeting anomaly, is to hold in hand the energy of an event that spanned billions of years and unimaginable distances. Each detection is a thread connecting Earth to the outermost regions of the observable universe, a reminder that the cosmos is not indifferent, but constantly in motion, endlessly expressive. Whether or not these expressions are messages remains unknown. What is certain is that humanity has learned to listen in ways it never could before, extending its senses across scales of time and space that once seemed inaccessible at the extreme. Edge of science, FRBs, are both a problem and a promise. They resist categorization, slipping between theories, hinting at new physics while defying confirmation. But it is in that resistance that they serve their truest purpose. They force the frontier to advance. They compel technology to grow sharper, algorithms to grow wiser, and imaginations to grow wider. They remind humanity that discovery is not a straight path towards certainty, but a continual expansion into deeper mystery. In their brevity, they embody both the fragility of human understanding and the immensity of what remains undiscovered. And so the edge is not fixed. With every FRB, it shifts outward, pulling science into terrains uncharted. Somewhere beyond the silence, beyond the static, beyond the limits of today's instruments, the universe continues to speak. Whether in the language of collapsing stars, in the trembling of space-time, or in the voices of others yet unknown, it speaks. Humanity has only just begun to hear. The mystery of fast radio bursts, dazzling and elusive, has drawn countless speculative visions. Yet within the discipline of science there remains a gravity, a steady pull toward explanations, grounded in the known forces of nature. For most astrophysicists, the extraordinary does not require the intervention of the alien or the supernatural. The cosmos, in its own architecture, provides engines of violence and beauty powerful enough to account for nearly anything observed. At the forefront of these explanations stands the magnetar, a neutron star so dense that a teaspoon of its matter would outweigh a mountain, and so magnetized that its fields could twist atomic structures across vast distances. In these exotic stars, the universe has built natural dynamos whose outbursts can, in a fraction of a second, unleash energies rivaling the output of entire galaxies. Evidence for the magnetar theory is compelling. In 2020, astronomers witnessed a giant flare from a magnetar within our own Milky Way, known as SGR 1935-2154, for the first time. A burst of radio energy from such a star bore a resemblance to the enigmatic FRBs observed from distant galaxies. It was not a perfect match. The flare was weaker, shorter, more modest compared to the titanic flashes seen billions of light-years away. Yet it was enough to anchor the idea that at least some FRBs are the cries of magnetars. They're magnetic, fields snapping and releasing titanic shocks into the void. Here was a natural mechanism capable of explaining both the speed and intensity of the phenomenon, grounded not in speculation, but in observation. Other mainstream theories point to collisions of compact objects, neutron stars spiraling into one another, or a neutron star consumed by the abyssal hunger of a black hole. These events are rare, cataclysmic, and final, producing gravitational waves, bursts of gamma rays, and, potentially, the fleeting radio signals now captured as FRBs. Unlike repeating bursts, such collisions could only explain the one-off signals, those that flash once and never return. They are the thunderclaps of cosmic endings, brief and absolute, leaving only silence in their wake. In this way, the diversity of FRBs, some repeating, some not, hints that multiple mechanisms may be at play, each written into the cosmos, with its own distinct signature. Beyond these explosive origins lies the possibility of amplification, subtle effects that do not create signals but sculpt them. Plasma lensing, for instance, may act as a magnifying glass on radio waves as they travel through the turbulent matter of interstellar and intergalactic space. Clouds of charged particles could focus or distort the signals, making faint bursts appear far brighter or splitting a single event into echoes. In this interpretation, the universe itself becomes part of the mystery, not merely as stage but as active participant, scattering, bending, and shaping the whispers that reach Earth. The signals are not only messages from their sources, but also records of every medium they have crossed, each distortion of another clue in the cosmic puzzle. Quasars and supernova remnants, too, play their roles in shaping radio light. The deaths of stars leave behind clouds of debris and shock waves of ionized gas that ripple through space like the aftershocks of earthquakes. When radio waves encounter such environments, they scatter, disperse, and polarize, carrying within Their distortions, the fingerprints of the places they have passed. Some FRBs may even originate within such chaotic regions, stellar graveyards, where magnetic storms and turbulent plasma conspire to release brief, violent flashes. What seems extraordinary at first glance may in fact be the natural behavior of a universe in perpetual creation and destruction. For most astrophysicists, this is the profound beauty of science, that the universe itself, through processes of staggering violence and elegance, can generate phenomena more astonishing than any human imagination. Magnetars twisting their magnetic fields until they snap, neutron stars colliding in the darkness, plasma clouds shaping light across billions of years. These explanations require no otherworldly intelligence, no messages from distant civilizations. They require only the forces already known to exist, pushed to their extremes, revealing the cosmos not as silent machinery, but as a symphony of fire and magnetism. And yet, even within these grounded explanations, there remains wonder, for to witness a magnetar flare, or the collision of neutron stars, is no less awe-inspiring than to imagine the hand of intelligence behind the signal. The natural world, in its raw ferocity, produces events that dwarf the creations of any civilization. In the end, perhaps the mystery of FRBs is not diminished by natural explanations, but elevated by them. A reminder that the universe itself is more imaginative than any myth humanity could devise. The investigation into these mainstream explanations has become a discipline of patience, precision, and relentless comparison between theory and observation. Each FRB, once captured, is dissected into its components, its brightness, its duration, the spread of its frequencies, and the way its polarization twists as it travels through space. These details are more than numbers, they are fingerprints, revealing the nature of the environment through which the burst has passed. A strongly polarized burst, for example, suggests it originated in a region saturated with magnetic fields, supporting the case for a signal with unusual dispersion, stretched across frequencies like a rainbow of radio light, points to vast oceans of plasma lying between the source and Earth. Step by step, the statistical weight of these measurements builds a scaffolding for the natural theories. Still, the mystery remains far from closed. The repeating bursts, in particular, challenge simple interpretations. Magnetar flares are explosive, violent events, but they are not infinite wells of energy. For a single star to flash again and again over years suggests a mechanism that is both destructive and sustainable, a paradox that astrophysicists struggle to resolve. Some suggest that magnetars might have multiple modes of activity: catastrophic flares that devastate their surroundings, and smaller tremors that release bursts without exhausting the star itself. Others propose that plasma lensing or intervening structures could make a single flare appear as multiple bursts, scattering echoes across time. In these possibilities, nature's hand is clear, yet its script remains difficult to read. Collisions, too, face their limits. A neutron star crash cannot repeat. Its outcome is final. Yet the majority of FRBs detected to date are one-off events, never repeating, vanishing forever after their brief appearance. Here, the collision models find their strongest ground, explaining the finality of these cosmic detonations. But the coexistence of both repeaters and non-repeaters has forced scientists to admit that no single explanation may suffice. The diversity of signals could reflect the diversity of astrophysical processes themselves, each mechanism lighting the sky in its own unique way. as if the cosmos were offering humanity multiple chapters of a story written in radio waves. Supercomputers and coordinated observatories have become the arbiters of this debate. By cross-referencing detections from facilities like CHIME in Canada, Parkes in Australia, and FAST in China, astronomers attempt to triangulate the conditions under which bursts occur. When signals show consistent properties across multiple instruments, the evidence for natural astrophysical sources strengthens. Polarization studies, for instance, have revealed that some bursts carry signs of passing through environments with magnetic fields trillions of times stronger than Earth's, aligning closely with magnetar predictions. Similarly, dispersion measures the stretching of signal across frequencies due to intergalactic plasma, confirm that many bursts originate from galaxies billions of light-years away, distances that rule out most forms of terrestrial interference. Each of these measurements narrows the field of plausible explanations, building a case for extraordinary yet natural origins. Yet, within this steady march of evidence, there lingers a note of humility. Every time a new detection seems to confirm a theory, another emerges that unsettles it. Some bursts last longer than predicted, others exhibit unexpected structures, while still others repeat with rhythms that defy simple magnetar models. These anomalies are not flaws in science, but reminders that nature rarely conforms neatly to human expectations. They force theories to evolve, to expand, and to incorporate the unexpected. For scientists, this tension between confirmation and surprise is not a source of frustration, but of vitality, proof that the mystery is still alive, the discovery has not yet ended. The consensus, if one can call it that, leans toward magnetars and other extreme astrophysical objects as the most likely culprits. Their existence is real, their energy is sufficient, their environments plausible. To imagine FRBs as the echoes of cosmic cataclysms is to stand in awe of the universe's raw power. It is a perspective both humbling and exhilarating, that humanity may be eavesdropping not on alien minds, but on the very machinery of creation and destruction itself. And yet, even within this grounded framework, there is a haunting awareness that what has been explained so far is partial, provisional, and incomplete. The bursts still arrive without warning, each one a challenge, each one a whisper that the universe has more to say than human instruments can yet decipher. In the vast silence of the cosmos, where stars are born and galaxies collide in quiet grandeur, science often treads a careful line between the known and the speculative. Yet there are moments when even the most cautious minds allow themselves to glance beyond the boundaries of established explanation. Fast radio bursts, in their brevity and brilliance, invite such glances. For while magnetars and collapsing stars may explain much, the enigma of these signals leaves a narrow corridor open, a passage into the realm of possibilities that stretch from the edges of physics into the imagination of civilizations yet unseen. One such speculation lingers on: the idea of extraterrestrial technology. If humanity, with its fledgling rockets and infant networks, already considers using directed energy for communication or propulsion, then what of a civilization thousands, perhaps millions, of years more advanced? Some physicists have suggested that FRBs might not be accidents of nature at all, but purposeful emissions, beacons sweeping across the intergalactic dark, or the exhaust of propulsion systems driving colossal spacecraft on scales beyond human engineering. In this vision, what is observed is not chaos, but intent, written in bursts of radio fire. The concept stretches further still. Imagine a stellar engine, a civilization that has harnessed the energy of a magnetar, one of the most violent objects in the universe, not as a hazard to be feared, but as a furnace to be controlled. Such a feat would dwarf the achievements of human history. The intense bursts of energy, incomprehensible by terrestrial standards, could serve as tools, signals, power sources, or even methods of manipulating matter on galactic scales. To some, this borders on the impossible. To others, it is the logical endpoint of a universe that gives rise to intelligence. Linked to this is the speculative echo of Dyson's vision, the idea of megastructures, encasing stars to capture their energy. A Dyson sphere, if built around a highly energetic star, could leave its mark on the cosmos in strange ways. The leakage of energy or deliberate bursts of it might mimic phenomena now attributed to natural origins. What if FRBs are not merely the voice of stars, but the byproducts of civilizations harnessing them? The question is not posed as a conclusion, but as a haunting suggestion, an invitation to consider that what humanity calls noise may in fact be architecture, the architecture of intelligence, written in light. These possibilities brush against the enduring weight of the Fermi paradox. If life is common, if intelligence should naturally arise in countless worlds, why does the universe seem so silent? The paradox presses against human thought like a locked door in the dark. Could FRBs be the first knock from the other side? Not a conversation, but the faint recognition that something else moves in the vastness. The irregularity, the rarity, the inexplicability of these signals grant them a strange allure. They may be natural, they may be alien, but in either case they underscore the limits of current perception. Others stretch speculation past even the reach of civilizations. Some theories propose that FRBs may be linked not to objects, but to space-time itself. Wormholes, the hypothetical tunnels connecting distant points in the universe, might flicker with energy when forming or collapsing. Higher dimensional ruptures, places where the fabric of reality itself tears and reforms, could radiate bursts visible across galaxies. In such visions, FRBs are not the voice of stars or civilizations, but the voice of the universe itself, its hidden scaffolding groaning under forces beyond human comprehension. There are even those who suggest a more poetic speculation still, that the universe is not merely a stage upon which matter plays, but a conscious system, unfolding thought as stars and galaxies, expressing awareness as bursts of energy. If so, FRBs could be whispers of that awareness, messages without language, signals without sender, a cosmos looking upon itself and its vastness, shimmering with moments of communication that life may one day learn to interpret. Science does not rest upon these fringes, but it does not dismiss them outright. Instead, it lets them linger at the horizon, reminders of how much remains unknown, how much imagination fuels discovery. Whether the bursts are engines or echoes, civilizations or cataclysms, the mystery itself becomes a mirror. In the fleeting brilliance of an FRB, humanity confronts not only the question of what lies beyond, but the question of what it means to wonder at all. Beneath the long arcs of northern skies, a quiet revolution is underway. In the Canadian wilderness, a vast array of metal cylinders stretches across the landscape, their silent frames staring upward like an orchestra of instruments tuned to the cosmos. This is CHIME, the Canadian Hydrogen Intensity Mapping Experiment, and though its design was never intended to chase cosmic anomalies, it has become the world's most prolific hunter of fast radio bursts. Unlike the giant single-dish telescopes of the past, CHIME listens broadly and continuously, capturing swaths of the sky in real time. In its data streams, fleeting bursts reveal themselves by the hundreds, each one carrying the signature of an event so powerful it can outshine entire galaxies for a millisecond. With CHIME's unblinking gaze, the universe no longer seems sparse in its whispers. It is alive with them, scattered across every corner of the sky, as if reality itself were punctuated by hidden rhythms. But CHIME is only the beginning. On the horizons of Australia and South Africa, engineers and astronomers are building the Square Kilometre Array, the most ambitious radio telescope ever conceived. When complete, it will stretch across continents, its thousands of antennas linked together to form a single, vast instrument with sensitivity and precision unlike anything humanity has wielded before. It will be able to trace the faintest of signals back to their origin, peeling away interference, mapping the structure of galaxies, and perhaps, finally, uncovering the true nature of FRBs. For scientists, the SKA represents not just another observatory, but the threshold of a new epoch in listening, a machine capable of hearing whispers from the dawn of time. Yet the quest is not confined to monumental machines alone. Across the world, citizen science projects open fragments of the cosmic library to ordinary people. Volunteers sift through radio noise, hunting anomalies, joining the ancient tradition of watchers under the stars. The work may seem humble, but history has shown how often chance, curiosity, and patient attention reveal what machines alone cannot. In the modern era, this partnership between human intuition and technological power has grown stronger, with algorithms now joining the search. Artificial intelligence, trained on oceans of data, learns to recognize signals too subtle, too complex, or too fleeting for human perception. These systems may one day uncover patterns hidden within the bursts, structures invisible to human eyes, but obvious to minds built from silicon. The effort extends beyond radio alone. Scientists now weave a tapestry of observations across the electromagnetic spectrum. When an FRB flickers into being, X-ray telescopes, gamma-ray satellites, and gravitational wave detectors are called into watchfulness, each offering another piece of the puzzle. If a magnetar erupts, it may speak not just in radio, but in light, in neutrinos, in the trembling of space-time itself. Coordinating these instruments transforms astronomy into a symphony of detection, where every wavelength is a voice in the chorus of the cosmos, and through these efforts, a quiet sense of imminence takes hold. The mystery of FRBs, once thought to be a handful of anomalies, has now become a frontier in its own right. The bursts are too numerous, too diverse, too strange to be dismissed as curiosities. They demand an explanation. Whether the answer lies in the convulsions of neutron stars, the architectures of alien intelligence, or the tremors of space-time itself, humanity stands on the verge of knowing. Yet the closer the answer seems, the greater the questions become. For every burst catalogued, another appears stranger than the last, as if the universe itself resists finality, ensuring that every solution opens a deeper mystery. The present moment feels like standing at the threshold of revelation, where the instruments are built, the data flows, and the interpretations multiply. Perhaps soon, the veil will lift, and the first coherent story of these signals will be written into the annals of science. Or perhaps the veil will only thicken, reminding humanity that the cosmos is not obliged to explain itself, that some mysteries exist to deepen the experience of wonder rather than resolve it. In either case, the pursuit continues, for in listening to the universe, humanity is also listening to itself, to its need for meaning, for connection, for understanding across the infinite dark. From the dawn of civilization, humanity has tilted its face toward the heavens and asked if someone or something was listening back. In ancient myth, the sky was not empty but alive with voices. Thunder was the anger of gods, comets their omens, eclipses their veils. The stars themselves were imagined as watchful eyes scattered across the firmament with intent. Long before radio telescopes, long before the physics of neutron stars or the mathematics of plasma, people already felt the weight of silence and filled it with stories. It was less about what the cosmos truly was, and more about what it reflected within a canvas onto which human beings projected their longing, their fear, their hope for communion beyond themselves. Now, in an age of supercomputers and precision instruments, the myths have been stripped away, but the longing remains unchanged. Fast radio bursts are not thunderbolts hurled by gods, but still they echo with mystery. They flash for a heartbeat and vanish, leaving behind riddles carved into the spectrum of radio light. The existential burden of listening persists. If the universe answers only with silence, does it mean we are alone, drifting in an infinite desert with no other travelers to meet? Or does silence mean that the voices are there, speaking in dialects too strange, too subtle, for human ears to yet discern? This paradox deepens the mystery, for it places humanity not at the center of the narrative, but at its fragile edge, struggling to hear a symphony that may stretch far beyond the narrow range of senses evolution has afforded. Yet, even if the bursts prove entirely natural, the wonder does not diminish. To know that magnetars, collapsed remnants of once mighty stars, can unleash energies rivaling what the sun produces in thousands of years, all within a fraction of a second, is to glimpse a reality far stranger than the myths once painted. These signals, however impersonal, are no less awe-inspiring. They are the universe writing its autobiography in fire and plasma, brief entries scrawled across the cosmic record. Humanity, in turn, becomes the reader, not the author, opening a book whose pages extend into realms where imagination falters. There is humility in this realization. Human science, so often celebrated as triumphant, is in truth young and unsteady, its instruments like the first crude glasses lifted to a vast and ancient text. What has been read so far is not even a preface. For every FRB recorded, millions more may have passed unnoticed. For every explanation crafted, a dozen new questions unfurl. The cosmic library is immense, and humanity has only begun to learn its alphabet. This is not a cause for despair, but a reminder of the privilege of being a species capable of listening at all, of recognizing that the universe has a voice, however fragmented and elusive. In this way, the mystery of FRBs is not merely astrophysical but deeply human. The bursts remind us that curiosity is not a luxury but a defining trait, that to exist as a conscious being is to reach outward, to strain against silence. The poetic symmetry is striking. The universe speaks in bursts, sudden and fleeting, and humanity strains to catch them, interpret them, and wonder. Each detection becomes less a solution than a mirror, reflecting back the shape of the questions we dare to ask. Perhaps the ultimate revelation is not whether these signals come from stars or civilizations, from natural chaos or intentional design. Perhaps the true meaning lies in what they reveal about us, a species suspended between knowledge and ignorance, refusing to surrender to silence, defined not by the answers it holds, but by the act of listening to the stars, again and again, as if each whisper carried the possibility of rewriting what it means to be alive in the cosmos. And so the listening continues, stretching across nights and decades, across continents and cultures, as dishes and antennas trace invisible lines through the dark. The mystery of the bursts becomes more than an astrophysical riddle. It becomes a meditation on human persistence. Civilizations rise and fall, but the act of listening endures, from the first firewatchers who charted stars with their eyes, to the engineers, who now weave arrays spanning entire landscapes. The thread is unbroken, a refusal to accept silence as the final word. Each fleeting signal is a reminder that patience is not passive but active, a discipline of hope that insists on the possibility of connection even when none is guaranteed. Philosophers have long argued that humanity's greatest achievement is not technology or conquest, but awareness itself, the capacity to reflect, to wonder, to feel astonishment in the face of vastness. FRBs, in their sudden violence and brevity, distill this truth. They are both too immense and too quick to belong to ordinary experience, demanding instruments, mathematics, and collaboration across the planet. And yet their deepest impact is not technical but emotional. They pull at something older than science, the intuition that the universe is alive with meaning, even if the meaning is beyond translation. In this way, the bursts are paradoxical, utterly indifferent in origin, yet profoundly intimate in consequence, speaking directly to humanity's need to not be alone. In the silence between bursts lies the heaviest weight. For most of the sky, most of the time, there is nothing but a quiet so total that it dwarfs imagination. Against this stillness, the sudden flash of an FRB feels like a defiance, a fracture. In the void, it suggests that the universe is not a dead expanse, but a stage where dramas beyond comprehension are unfolding. Whether those dramas belong to collapsing stars or to civilizations harnessing forces unknown, they awaken a sense of participation, the feeling that to listen is itself to be part of the story, even if only as witness. Perhaps this is the most profound truth the bursts carry, not evidence of others, not proof of gods or machines, but a mirror of the species that listens. To tune antennas to the stars is to confess an unwillingness to remain within the limits of Earth, a refusal to let the boundaries of knowledge close in. The FRBs may never yield their final secret, or perhaps they will one day reveal a revelation, so vast it reshapes human destiny. But until then, they are emblems of wonder, cosmic sparks that remind a fragile species that curiosity is its greatest survival instinct. And in this quiet recognition, the story closes not with an answer, but with an opening. For the universe speaks in bursts, and humanity will go on straining to hear, not because it must, but because it cannot help itself. Listening is not just what humanity does, it is what it is, a question etched into consciousness, cast outward into the night, awaiting echoes that may yet return.